Welcome back to our Work, Power, and Machines unit. This is the second lesson in our unit. Today we're talking about power. If you'll remember, our last lesson was over work and what it means for an object to do work on another object. So keeping in mind what we discussed in the last lesson, I want you to try to answer this question. When is more work done? When you run up a 1 meter flight of stairs or walk up a meter flight of stairs? Now, hopefully you said that they both require the same amount of work. Remember, work has a very specific definition in physics. For work to be done on an object, that object has to move, and it has to move in the direction of the applied force. Now, when you think about the situation of walking versus running, even though it might be more exhausting to run up the stairs or more tiring to run up the stairs, you're actually covering the same distance, whether you walk or run, and you're applying the same force. So our body weight would be considered the force. And if I walk up a meter flight of stairs, I'm applying the same downward body weight force as running, walking, same force. So they would be the same amount of work. Now we're going to tie this into power. So power and work mean a little bit different things when we're talking about physics. So our new definition today is going to be the rate at which work is done. And we say that is power, and we can measure power with a formula. So we're getting a new formula. Now, in the last lesson, we learned that work is force times distance. Today, we're going to learn that the formula for power is work divided by time. So this is going to be a rate. Power is measured in watts. So watts is going to be the unit that we use, and you can abbreviate that with a lowercase w. If you use the pie chart, I put the pie chart on the slide so that you can jot that down in your notes. Again, power equals work divided by time. All right, so I'm going to go through a series of practice problems. I want you to pause the video, work out each of these problems, and then unpause just to make sure that you get the right answer. So number one, while rowing in a race, John does 3,960 joules of work on the oars. He's going to do this in 60 seconds. So if we want to know his power output in watts, all we have to do is take work and divide that by time. So do that now and see what you get. Now, hopefully you got 66 watts as your answer. So 66 would be the value, and then watts, of course, is our unit. Now, in number two, this one's a little more tricky because you have to know what you're looking for. So using a jack, a mechanic does 5,350 joules of work to lift a car 0.5 meters, and all this is going to happen in 50 seconds. So if I want to know the mechanic's power output, remember you're going to do work divided by time. So pause the video now, see what you get. Now, hopefully you got 107 watts. If you did not, perhaps you used the extraneous piece of information that was in the word problem. So if you notice, we gave the distance that the car moved, but you don't have to have distance to be able to do a power word problem. It's just work divided by time. So you actually did not need the 0.5 meters. So 107 watts would be the answer. For number three, Anna walks up the stairs on her way to class. She weighs 565 newtons, and the stairs go up 3.25 meters vertically. So if I want to know her power output, if she can do all this, climb the stairs in 12.6 seconds, use the formula, pause the video, figure it out, and see if you get the correct answer. All right, now this is a two-step problem. Remember, to figure out power, we've got to have work. And they didn't give us work in this word problem. They did give us force and distance though, so with those two bits of information, we can actually solve for work. So work is force times distance. So you had to do 565 newtons times 3.25 meters first, get that answer. And then you divide that answer by 12.6 and you would get 44.84 watts. 44.84 watts. Now I've got some more practice problems for you. So after the video, work those practice problems out, and I will see you in our next video, which is over machines.